Okay, I'm going to have you do these problems and then keep going. Do not stop. I'm going to have you do as many as you can in about 10 minutes, and then I'm going to have you count them up at the end and put that number with a circle around it at the top of your paper. So here we go. First one, simplify root 20. Find two numbers where one of them is a perfect root. Would not want to use 10 times 2. Even though 10 times 2 gives me 20, those numbers do not have a perfect root in it. So if I use 4 times 5, that will be better. So 20 becomes the square root of 4 times 5. Notice I'm always writing the perfect root first. And then when you split it into two parts, square root of 4 to get a whole number 2. Bring down the square root of 5 because you can't do anything with it. So that becomes 2 root 5. 4 squared is not ever 4 times 2. Never do 4 times 2. Never ever. 4 squared is 4 times another 4, which gives me 16. If I square something square rooted, remember this is not 4 times 4 right here. This is root 4 times another root 4, which gives me the square root of 16, which gives me back to my answer 4. So whenever you square something already square rooted, those will cancel away and just leave you that whole number always. Alright, Pythagorean theorem problems. These are the legs. Make sure those go together in the Pythagorean theorem. Remember, Pythagorean theorem is a squared plus b squared equals c squared. Remember, you could always flip that around if you want. So I'm going to solve for c here. So I'm going to write it with the c on the left-hand side. C squared equals 3 squared plus 2 squared. So that unknown hypotenuse gives me 9 plus 4. So c squared equals 13. Right there, I need to square root both sides. Show me that you're square rooting this side, square rooting the other. Show me that these cancel away and just leave me plain old c. So that answer is c equals root 13. I cannot do anything with 13. I just have to leave that alone. Number 5, again, find the legs. Here's my right angle. The two legs are on either side of that right angle. Those will always go together in the Pythagorean theorem. So when I plug them in, that will be 4 squared plus the unknown a squared equals the longest side, the hypotenuse, 6 squared. 4 squared is 16 plus a squared. 6 squared is 36. Before I could square root anything, I need to subtract that 16 on both sides. Bring down the a squared. 36 minus 16 is 20. Right there, square root both sides. Show me this inverse operation. Show me those cancel away and just give me plain old a. And then all I have to do is look at that 20. Can I break that down? Unlike the problem before, 13 can't be broken down, but 20 can. 20 again is made up of 4 times 5. And when you break that apart and split it, I get 2 root 5. Alright, number 6. Again, identify the legs. These are the legs. These are on either side of that right angle. Circle them. Put them together. So this is going to be 2 squared. And I'm going to solve for c, so I'm going to write c on this side. The longest side, c squared, equals the 2 legs squared. But be careful. I am squaring the square root of 4. That does not give me 16 right there. This gives me c squared equals 4 plus another 4, which is c squared equals 8. I need to square root both sides. Those cancel away and just leave me c. I need to look at 8 and see if I can break that down. And yes, 8 becomes 4 times 2, which breaks up into 4 times root 2. Square root of 4 gives me a whole number 2. Bring down the square root of 2 because I can't do anything with it. That is my answer. 7 is a trick question. There is no right angle here, so you cannot use the Pythagorean theorem. You'd have to write not enough information. If I had given you the actual coordinates of these pieces, then you would be able to use the coordinates and the distance formula to find that distance right there. But I did not give you any coordinates. I did not have a right angle on this triangle. There is not enough information. You cannot find C with that not enough information. So that was a trick question. That is not enough info. Look for that right angle. If it's not a right triangle, you could never use the Pythagorean theorem. Keep on going. Do not stop. If you need to keep doing problems in your notebook, feel free. Count those as part of your total. Good luck.